好，那我们接下来开始影片教学。
This is Walton Hall in Yorkshire. In 1835, it was home to a wealthy and somewhat eccentric gentleman. They said he could be seen regularly walking the grounds barefooted and in the company of an aging donkey. Now, they must have been a pretty shabby pair, but between them they took part in one of the more extraordinary experiments of the 19th century. An experiment that would lead to significant breakthroughs in medicine and in surgery and would transform our understanding of poisons. Go on in. Pain, pus and poison has charted the many colourful characters who, over the past 200 years, created the medicines which protect us from pain, infectious disease and even death. Through their heroic efforts, chemicals, almost magical in their effects, were discovered, scrutinised, and finally exploited. In this programme, I'll reveal the remarkable science behind perhaps the most unexpected source of many modern medicines: poisons. Poisons that include the planet's most deadly substances. A couple of kilos would kill every human on the planet. From the natural world to the man-made, it's a tale of greed, tragedy, hope, and chance.
What started out as a science expedition looking at bugs turns into a cancer therapy. To me, I think that's one of the wonders of science.
So, just how far can we go into unlocking the benefits of poisons?
All medicines are poisons, and all poisons should be considered as potential medicines.
他这边就讲到说，就是所有的药物其实都带有一点毒性，那所有的毒物其实都有被转化为药物的潜力。那这就是刚刚讲到这一节课它的主要的一个重点。
Poisons have, throughout history, been used to take life, whether by suicide, assassination, or murder. And yet, until the 19th century, surprisingly little was known about how they actually work. Someone who helped change that was Charles Waterton, the colourful squire of Walton Hall.
He was considered very eccentric. He used to sometimes hide under tables and bite people's legs at the dinner table. He was double-jointed. He could scratch behind his ear with his big toe.
他说他是一个双关节的人，他可以用脚踢到自己的耳朵。
Quite strange.
As well as being an eccentric, Waterton was also a man with a passion for knowledge. He travelled the globe, collecting the exotic and the unusual. Not always simply for scientific study.
He created a taxidermy piece after a customs officer had upset him by charging extra duty on the specimens he brought back from Guyana. He changed the rear end, the arse of a howler monkey, to look like this customs officer's face, which is possibly the perfect insult.
Waterton spent nearly 20 years living in the Amazonian rainforest, where he befriended one of the Amerindian tribes called the Makuzi. Now, what Waterton was really interested in was a closely guarded secret, a poison that could kill almost any animal, and which occasionally they used to kill each other. He managed to get the recipe from the Indians. It's got some really interesting ingredients. We've got the fangs of the labari snake, and there's also apparently some black ants you pound in, which are so venomous their sting alone produces a fever. But it's actually not those things. The key ingredient is a vine which grows in these wilds, which is called woorali. It is from this that the poison takes its name, and this is the principal ingredient. This vine was later identified as Strychnos toxifera, and the poison from it is known today as curare.
他从亚马逊河流域原住民那边学到从植物提取 curare 箭毒素，然后作为猎杀的一个武器。他们涂在那个弓箭的箭头上。
Although it is 200 years old, it's still active, so I'm not going to touch it. Now, Waterton himself brought it back because Europeans were absolutely fascinated by curare, and no one else has succeeded in getting the really good stuff in quantities, certainly not enough to do proper experiments with. Back home, Waterton was approached by leading vet Professor William Sewell, an eminent surgeon, Sir Benjamin Brodie, who wanted to find out exactly how curare killed its victims. Brodie had already tested the poison on small animals, but now wanted to experiment on something larger. So they used a donkey. They injected the unfortunate donkey with enough curare to kill it. Then, when it collapsed and stopped breathing, they quickly performed an emergency tracheotomy. What you do is you get a knife and you slit your way into the windpipe here. And then what they did is they inserted a pair of bellows into the windpipe and pumped away. And they really had very little idea of what they were doing. They didn't know how long they would have to do it for. After about 2 hours, the donkey sort of recovered enough to look up and sort of stare at them. So they stopped, and the donkey then collapsed. So back to the bellows again. They kept this up in total for about 4 hours. Until finally, as Waterton wrote in his journal, the pumping had saved her from a final dissolution. She rose, she walked about, without obvious agitation or pain. Yes.
4小时后，他就正常站起来走掉了。刚刚的呼吸机麻痹就没了。
And of course, the donkey had demonstrated something remarkable. A discovery that would have an unexpected and far-reaching impact. They had shown that curare acts on specific muscles, including those that enable you to move and breathe.
呼吸机麻痹。
Whereas other muscles, including, crucially, the heart, were completely unaffected. As long as you can keep the patient breathing, he, she, or it should survive.
The key aspect of curare is that it's a muscle relaxant. All your voluntary muscles will stop working, including the respiratory muscles.
The three scientists had shown it's possible to keep a patient alive while their body is rendered immobile, relaxed by curare. Now, in the early 1800s, this discovery had no obvious application, but 100 years later, it would transform surgery.
后来就被应用到手术上。
In the 20th century, one of my favorite self-experimenters, Dr. Fred Prescott, deliberately injected himself with a pure form of curare to demonstrate that it is safe to use as a form of muscle relaxant in surgery. In fact, since the 1950s, most people who've had major surgery will have benefited from curare or one of its modern equivalents. And the donkey? She was retired to Walton Hall. Charles Waterton wrote in his diaries, "She shall be sheltered from the wintry storm, and in summer she shall have the finest pasture. She will end her days in peace." In fact, she did live another 25 years, and when she finally died in 1839, she got her own obituary in the local paper, detailing her contribution to medical science. In Victorian Britain, life was harsh and often cut short. Life insurance suddenly became a boom industry. This led to a surge in financially motivated murders, many by poison.
因为保险的发达，所以很多人买了毒药，去制造谋杀。
for pharmacy and forensic science. One of the most high-profile Victorian cases was a woman called Mary Ann Cotton.
Mary Ann 这一个女生。 它是里面的算是一个谋杀的一个很经典的案例。
She was married 4 times. 3 of her husbands, heavily insured, all died. The one who survived seems to have done so because he refused to take out insurance, so she left him.
只有一个不买保险的老公活了下来。
In all, 10 of her children died of what appeared to be gastric-related illnesses.
10个小孩都因为胃部疾病而过世
But
了，
fortunately, most of them were insured.
但都买
Her
保险。
mother, her sister-in-law, and her lover also died, and in each case, she benefited. By 1872, the unfortunate Mary Ann had lost an astonishing 16 close friends or family members. But there was one left, her 7-year-old stepson, Charles Cotton. Now, she tried to give him away to the local workhouse, but they wouldn't have him without her. Young Charles soon died. The manager of the workhouse, however, got suspicious when he heard about the death of the child, and he contacted the police. They investigated and exhumed the body of young Charles. They suspected foul play and, not surprisingly, wondered if Mary Ann had poisoned him. They thought they knew how she'd done it. With arsenic.
砷就是砒霜。
Arsenic was an excellent way to kill somebody. It's known as a cumulative poison, which means that you don't excrete the dose. So in other words, the more you take, it builds up more and more in the body.
就剂量累积。
And it was very easy to administer in food. So it just looked like somebody was dying of natural causes.
加在食物里并没有特别的味道。
The trial of Mary Ann Cotton would hinge on whether they could find traces of arsenic in the body of Charles Cotton. Now, forensic science was still in its infancy, but they did have a good test for arsenic. The reason for that is there was an awful lot of arsenic poisoning around.
接下来就要测试到
This
底
test
是不
is
是砷
called
中毒
the
了。
Reich test, and it was the one used to discover whether Mary Ann had poisoned little Charles. A sample from the boy's stomach and intestines was heated with acid and copper.
加上酸跟铜，把它
If
的
arsenic
肠
was
组织
present, the
一起
copper
煮。
would turn dark grey. And when placed on paper soaked in mercury bromide, produce a telltale yellowy brown stain. And
然后
when they
经过
did
反
this
应，
test
铜会
on the
变灰。
body of poor little Charles, they discovered that he had indeed died of a lethal dose of arsenic. His stepmother, Mary Ann, was convicted of his murder on the basis of this, and she was hanged in Durham jail in March 1873. She was never taken to trial for the mysterious deaths of her mother, 3 husbands, 2 friends, and 10 other children. Throughout the 19th century, tales of sinister poisoners and unfortunate accidents filled the newspapers. And it was because arsenic was such a silent and prolific killer that some of the earliest techniques in forensic science were developed. But arsenic was about to do more than that. It was about to shape the development of the modern drug industry. Now I'm feeling quite nervous because this stuff is really, really nasty. It's actually a mineral, and even a tiny, tiny amount, less than 1/100th of an ounce, would kill you. As a poison, it is almost unrivaled because it's completely tasteless, dissolves in hot water, and it takes so little to kill. I'm going to put that back in there, and then wash my hands. Arsenic trioxide was marketed as a rat poison.
最后3氧化二砷因为无色无味就被拿来当老鼠
Children
药了
would。blithely collect it from the shops, along with tea, sugar, and dried fruits. A fact satirized in this Punch cartoon from 1849. And yet, there was clear evidence of it being used to murder people. So pressure was growing to bring this deadly poison under some sort of control.
The Pharmaceutical Society, along with what became the British Medical Association, got together in 1849, went to Parliament and lobbied for a new law to actually stop these poisonings. As a consequence, the new act was passed, which is the 1851 Arsenic Act, which greatly restricted the sales of arsenic.
The new act said that if you were selling arsenic over the counter, then you had to keep a record. You also had to know the person you were selling it to. And finally, in future, all arsenic would have to be coloured with soot or indigo. So presumably, if your husband or wife was trying to poison you, then you had a better chance of detecting it. It had even been proposed that women should be banned from buying arsenic. But that measure didn't make it onto the statute book. Although the Act restricted who could buy arsenic, it made no mention of who could sell it. So inevitably, the deaths continued. A few years and many murders later, Parliament finally introduced further laws to restrict the sale of the more obvious poisons. More importantly, they also created the trade of chemists and druggists. The Arsenic Act and other acts that followed finally brought arsenic and a whole range of other dangerous chemicals under some sort of control. Now, I do think it is gloriously ironic that it was from all these poisonings, accidents and murders that the modern legitimate business of pharmacy emerged. At the start of the 19th century, poisons had been mysterious and deadly compounds, convenient for killing yourself or others. By the middle of the century, a more rational understanding of how they worked was emerging. And, along with a legal and professional framework designed to control their use, it would lead to a new era of scientific discovery. This is belladonna, deadly nightshade, and there is certainly enough there to kill me. Now, belladonna in Italian means beautiful lady. And that's because in the past, elegant ladies would get the juice from this plant and they would use it to dilate their pupils in the hope that it would make them look more attractive. In the 19th century, they managed to isolate the active ingredient from the belladonna plant. It's a substance called atropine. And ophthalmologists started to use this to help them examine the eye. Now, I have the modern equivalent here, and I'm going to put some in my eye to see what happens. Oh, God, that does sting. Over the last few minutes, the focus in this eye has gradually gone. And I think you can tell that my pupil is a great deal bigger in this eye than that eye. But am I more attractive? One of the reasons why having a big pupil is supposed to make you look more attractive is because when you look at somebody and you find them sexually attractive, then your pupils expand. So it's really just me saying to you at this moment, I find you very, very attractive. And that's why you find me very, very attractive.
他用了一个导因为果，因为看到具有吸引力的人，瞳孔会放大，所以你先把瞳孔放大，让别人觉得你看起来很有吸引力。
And yet, oddly enough, the best treatment for atropine overdose turned out to be.
但是视力会模糊哦，所以不要乱用，你会看不清楚前方哦，结果撞到另外一个就不好了。接下来应该是一战。
In 1864, in Prague, a doctor was summoned to treat 4 prisoners who had broken into a local dispensary and thinking they were drinking alcohol, had drunk a large quantity of liquid containing atropine. When the doctor got there, they had clear signs of atropine poisoning. The men were seriously ill, lying prostrate on the ground, vomiting profusely, with these huge dilated eyes.
除了恶心呕吐之外，最明显的阿托品中毒就是瞳孔放大，很典型的一个急诊的一个基本判断。
Poison the men even further. But this time,
结果他要用以毒攻毒，
extract of calabar bean.
用一个
Calabar beans contain a number of pharmacologically active alkaloids, one of which is physostigmine.
有效成分是 physostigmine，
unlike
毒
atropine,
扁豆碱。
The hope was it could also reverse the other more serious effects of atropine.
要去逆
The
转
doctor
atropine
felt
的
he
作
had
用。
nothing to lose. So he took the man who was sickest, whose temperature had gone up and who really looked as though he was on the brink of death, and he got him, not without difficulty, to consume some of this second poison. Within a few hours his temperature had come down. Within a day he was completely cured.
Calabar beans and atropine have opposing actions. They can be used to
因为它们的
cancel
反
each other
向
out.
拮抗
So
作用。
effectively, one can be used as the antidote to the other, either way around.
是
And it
副
wasn't
交感
long
的致效剂
before
跟拮
poisons
抗剂的
began
一
to
个
be
作用。
commonplace in a physician's drug cabinet. In fact, these days, atropine is often used to reverse the effects of insecticide poisoning, and is also used to treat some forms of heart disease.
结果现在 atropine 被用来作为解毒剂跟心脏的一个，如果心率过慢的话，打一支
During the
atropine 是最
19th
快的。
century, researchers looking into poisons were on
在
the
ICU
whole
也很常用。
trying to find ways to make them more productive, more beneficial. At the start of the 20th century, things took an altogether bleaker, darker turn. World War I.
一战
It would leave 17 million people dead or missing in action. It was a living hell. And it was made even more hellish by the work of industrial chemists. In July 1917, troops based in Ypres, Belgium, reported a strange peppery smell in the air and a golden shimmering cloud that surrounded their feet. Within 24 hours, they had started to itch uncontrollably, and they came up in horrible, painful blisters and vile, incurable sores. Those who had inhaled too deeply started to cough up blood. The troops had been poisoned by mustard gas.
它用的是一个 mustard gas 芥子气、芥子弹。
Gas masks like this one were state-of-the-art at the time, but they were pretty useless against mustard gas. The problem is, mustard gas can be absorbed through the skin. Even if you were fully clothed, you were not fully protected. Gasping, spluttering, drowning, it could take up to 6 weeks to die, and it was a terrible death. Now, mustard gas was not the first of the poison gases. It was actually one of a number that had been weaponized by the Kaiser Wilhelm Institute under the directorship of a man called Fritz Haber. Fritz Haber was a professor at the prestigious University of Karlsruhe and was married to fellow chemist Clara Immerwahr. Haber would go on to win a Nobel Prize in Chemistry, but he also played a major role in the manufacture of chemical weapons.
He really pressed the Germans, who the German military didn't have much regard for science, pressed the Germans to see what science could do in providing them with explosives and in providing them with chemical weapons, and he oversaw the first use of chemical warfare on the Western Front.
He saw it as an efficient way to fight a war, and he didn't think it was especially inhumane. After all, he said, death is death, however it is inflicted. His wife, Clara, pleaded with him to stop working on gas warfare. He angrily and publicly denounced her as a traitor. Gas warfare was a horrific but extremely effective new weapon. It not only crippled and killed, but also instilled terror right across the battlefield.
casualties from the first use of EPA were estimated at 5,000 to 10,000 dead, with many, many more injured. And Harbour was delighted, as were the German military.
Harbour was promoted to captain and he returned to Berlin in triumph. But the couple continued to argue because Clara was deeply unhappy with what he was doing. Harbour, however, felt that he had an absolute scientific and patriotic duty to continue working in chemical warfare. Finally, and tragically, Clara took matters into her own hands. In the middle of the night, Clara silently removed her husband's pistol from its holster. She stepped outside, and then she shot herself through the heart. Later that day, Fritz Harbour left for the Eastern Front to oversee the next gas release against the Russians. He left behind his grieving 13-year-old son, who had been the one to discover his mother's dead body. Harbour continued to enthusiastically promote the use of poison gas, and his colleagues would go on to develop even more deadly nerve gases. One reason why World War I became known as the Chemist War. But the story of mustard gas does not end here. 20 years later, with World War II looming, researchers at Yale University School of Medicine retreated to their labs to try and create antidotes to mustard gas.
耶鲁医学大学他们要试着找到芥子弹的一个解毒剂，因为 World War II 又在酝酿了。
discovered would lead them into a very different kind of battle. Two of the doctors involved were Louis Goodman and Alfred Gilman.
就是药理的大家 Goodman and Gilman。很多参考
Working
书
with
就是那个。
libraries, they delved into the medical records of soldiers who had been exposed to mustard gas in the First World War. And what they found, amongst other things, was that these soldiers had surprisingly low white blood cell count.
结果他们发现，在一战中吸入的那些军人，他们血中白血球极低极低。
Cancer.
他们就想到，那如果是癌症病人呢？说不定有用。
These genetic mutations either promote excess cell growth or remove the normal safeguards that limit cell division. Either way, the cell begins to divide uncontrollably. One type of cell that is particularly prone to mutation is the leukocyte, or white blood cell. Goodman and Gilman thought to themselves, if mustard gas can destroy normal white cells, perhaps it can also destroy malignant ones. It was certainly worth a go.
说不定芥子弹可以抑制恶性的增生，白血球增生。
They looked for a human volunteer with white blood cell cancer to test their theories on. They found a patient with advanced lymphoma, known to us only by his initials, J.D.
给他 JD 的病人，这时候
These are J.D.'s original medical notes, which were lost for nearly 70 years. And I'm the first person outside the Yale medical community to lay my hands on them. They tell a fascinating and poignant story. J.D. was a Polish immigrant in his 40s,
一个波兰
a
人
metal，worker.
波兰移民，
He was riddled with cancer and had a massive tumor on his jaw.
下颚有一个
When
大
he
的
first
肿
came
瘤。
in, the tumor had progressed to the point where he could not swallow, he could not sleep at night, he could not fold his arms across his chest because the lymph nodes and cancer under his arms were so massive, and he was really encased front and back by tumor and up to his face, and he was just absolutely miserable.
His doctors tried everything they could, but the prognosis was not good. They had a case conference and concluded it with this line: "The patient's outlook is utterly hopeless on the present regimen." With nowhere else to turn, J.D. agreed to try the experimental drug based on deadly mustard gas.
结果他是第一个要试验的病人。
The notes say that at 10 a.m. on the 27th of August 1942, they gave him the first injection, what they call synthetic lymphocidal chemical, but which was in fact nitrogen mustard. Because of the war, even JD's treatment was a secret. They couldn't name nitrogen mustard. In the records, it was simply called
他们只能谎称是用个合成的白血球，不能讲说是用芥子弹来治疗。
And then again, X given at 9:30 a.m. the following morning.
甚至这药物都是代号。
He received a number of treatments using nitrogen mustard, and with each one he became a little bit better. He could actually sleep at night, he could swallow, he could eat, he was much more comfortable. The pain became minimal, and he was absolutely thrilled.
Although not fully understood at the time, nitrogen mustard works by binding to the DNA of dividing cells. This triggers the cell's self-destruct mechanism. Instead of dividing, the cells shut down and break apart, and the cancer, hopefully, is destroyed.
结果真的有用。
This was the first time that a drug had been used to treat cancer. This was monumental. I mean, it was a huge moment in the history of medicine. It is the beginnings of what we now call chemotherapy. And very strange to think that it all started in the horrors of the trenches of the First World War. All the chemo drugs that followed have had the same basic mechanism of action. They are poisonous to living cells.
后面的 chemotherapy 就是化学疗法都照这条路，就是对活的细胞有害的物质，就可能是化疗的一个用法。
For the treatment of some cancers. But cancers are persistent. Even today, the prospect for people with advanced cancers is often poor. For JD, treatment came too late.
结果治疗太晚了 ，JD 后
To
来
say
还
that he
是
enjoyed a few
挂
months
了。
is probably accurate, but ultimately he followed a downhill course.
JD, the world's first chemotherapy patient, survived for 6 months.
只存活了6个月。
There's just one entry
不过 quality 有
for the
变化，
1st
大家看到
of。December 1942. It simply says, died. JD died peacefully, unaware of the impact his life and death would have.
His story pulls the strings of your heart. It really does. And I think that he was a sad person with few friends with a devastating disease. And he made a huge contribution to management of cancer. So we are grateful to him for that, and we share his agony at the same time.
The field of chemotherapy, and indeed the very idea of using poisons as medicines, poses fundamental questions about toxicity. How do you decide which substances are poisonous and which are not?
这是一个根本性的
After
问
all,
题。
even the ancients realized that poisonous is a relative term.
毒物是一个相对
All
论，
substances are poisonous. There is none that is not poisonous. Now that's according to 16th century doctor and chemist Paracelsus. He goes on to add, it is simply the dose which determines whether a substance is poisonous or not.
后来他们有个简
Even
单的方
water
法，
can be lethal
要
if you
用
drink
多少
enough
剂
of
量
it.
才会致死
Too。much causes
来
brain
决定
cells
它
to
是不是毒
swell,
物。
which can lead to coma and death.
水喝太多也会中毒，也会挂掉。
So how much water would I have to drink for it to kill me?
但水不是毒物
About
哦，
7 litres drunk over a few hours. That would leave me with a 50-50 chance of surviving. And when it comes to coffee, about 100 would probably finish me off. And it's not just the amount that matters. The toxicity of a substance can depend on what species you are.
物种也很重要，每一个物种的
Now,
反
I
应不一
absolutely
样。
love chocolate. If I were to eat a bar this big, then it would probably make me feel a little bit queasy, but nothing worse. However, it would be a very different story if I was a dog like Dolly here, because chocolate is very bad for dogs. 2 bars this size on a dog this size could well be lethal.
所以
The
狗
thing
不
is,
能吃
it
巧克
contains a
力，
substance called theobromine, and
因为里面有
theobromine in
theobromine
dogs causes vomiting, heart problems, and convulsions. So this is for me and not for you.
可可碱啊，可可碱跟咖啡因啊、茶啊，这些都是会让心跳升高啊。所以喝茶、喝咖啡这些，它热线会变快，不是没理由的。对啊。
Nonetheless, it is extremely useful to have a comparative scale of how toxic various substances are.
体
One
型
measure
还
of
有物种
lethality
都要
is
考虑
the
进去。
LD50, the lethal dose 50%. In other words, how much of a substance would kill half of these mice?
LD 50
Although now rarely
这个
tested
剂
on
量会
humans,
造成这个物
the
种
concept of
50%
LD50
的
has
死亡率
stuck.，
就是一个
To allow
毒性的
for
判断。
size, doses are given per kilogram of body mass. On a standardized LD50 scale, water comes in at greater than 90,000 milligrams per kilogram of body mass.
水要喝这么多，
Pure alcohol is fatal to half the population at
然后酒的
7,000
话是
milligrams
每
per
公斤
kilogram,
7000
while
个
caffeine
milligram。
weighs in at 192.
咖啡因
Arsenic has an
这是刚刚
LD50
的
of
砷
14.
那个砒霜
Curare is lethal at only
箭毒
0.5.
curare 只要0.5 milligram
So
per
while
kilogram。
anything can be poisonous, substances with an LD50 less than 100 milligrams per kilogram tend to be called poisons.
他们定义低于
On this
100的
scale,
话
most
就称
chemotherapy
为毒物
agents,。including nitrogen mustard, would register between 1 and 4 milligrams per kilogram.
化疗的话大概是1到4，化疗药物大概是1到4。
By the 1950s, researchers had turned some poisons into effective drugs. Natural plant poisons like curare were being used in surgery, and synthetics like
箭毒被
nitrogen
用来当了
mustard
手
were
术，
having an impact on cancer.
然后芥子弹被用来应
They
用
were
在
just
化
a
化
small
疗上。
part of a new enthusiasm for pharmaceutical products. But in this dash for cash, the authorities overlooked the fact that while poisons can be medicines, medicines can also be poisons. It was only a matter of time before something went badly wrong. Amongst those rushing out new drugs was a German company called Chemie Grunenthal. Staffed by many former Nazis, they were searching for lucrative new medicines and had created a chemical that looked particularly interesting. Structurally, the drug was very similar to barbiturates, a class of drug that was then widely being used for anyone who had a sleep disorder. So the company decided to send it off to doctors and get them to try it on their patients who had sleeping problems.
德国一家 Chemie 的药厂对一种 barbiturate 很有效，很有兴趣，他们说服医生拿来当安眠药使用。
colds and headaches.
Oddly enough, I mean, it was a sedative, but it was also known to be quite useful in morning sickness for pregnant women.
对于孕妇的晨吐很有效，
under the brand name Distaval.
但他忽略了一个问题，
By
这个药并
1960,
没有做
Distaval
实
was
验。
sold throughout Europe, South America, Africa,
结
Canada,
果欧
and
洲、南
Australia.
美、非洲、加拿大都销售了。
Around this time, the number of babies being born with deformed or missing
悲剧要来了。
limbs and organs, well, they started to rise. Initially just a few, but then the numbers took off. Now, this was clearly really distressing, and something was going on. The problem was the doctors didn't have a clue what. Several traumatic years passed before the cause was finally found, when a young Australian doctor looked at the mothers rather than the babies.
结果
The only
有
thing
一
he could find
在
was
这个
that
时
these
期之
women
后
had all
出生了一
suffered from
堆海
morning
豹质的
sickness
宝宝。
in the early months of their pregnancy, and they had all been prescribed the drug Distaval, which is now more commonly known by its generic name, thalidomide.
学名大家比较
It has been
熟，
estimated
沙利多
that
曼。
around 10,000 babies were severely disabled by thalidomide, half of whom failed to live to adulthood.
结果这些
The
宝宝大
situation
多都
in
没活
America,
到成年。
however, was very different. It was 1960, the year before the link between thalidomide and birth defects would be made. Frances Kelsey was just starting out a new job at the Food and Drug Administration. Her first assignment was to review an application to market thalidomide. Since it was already on sale in the rest of the world, and since no one yet knew that it caused birth defects, it should have been a case of simply approving it.
理论上，其他国都有销售，也没有什么太大问题。美国应该也要能够进口才对。
Here's a person who was very well trained.
但是 FDA 里面的一个 Kelsey 的官员他不同
And
意。
so when she saw the application, she was kind of appalled. It struck her more as testimonials than good, solid clinical research. And she sent a letter responding to the
缺
application
少临床的
saying
证据
that in its present
更多
form,
的一个
it could not
实证
be accepted and
所以他不
to
接受。
submit additional data.
Another application was submitted to the FDA. But Kelsey was still not convinced by the safety data. So despite mounting pressure from
安全性的
the
data 还是不过。
manufacturer, she again refused thalidomide a license.
还是不发他的许可证。
There was a back and forth between FDA and the Merrill Company. The Merrill Company was getting quite annoyed, honestly, threatening to go to not only the supervisor, the head of the Bureau of Medicine, but the commissioner of FDA. But she stood her ground. She stood her ground as a scientist. She stood her ground as an FDA official who was, of course, had to uphold the law, and the law required that the drug had to be safe. She persevered through this whole process.
所以他坚持整个原则跟那个法律。
allow thalidomide a license. When in 1961 the facts finally came out, Americans appreciated just how close they had come to sharing in what was by then a worldwide tragedy.
所以美国
Frances Kelsey
这一次
was
就
given
没
an
有遭受
award
到这
by
个
John F.
悲
Kennedy
剧。
in recognition of her outstanding work.
甘乃迪也直接接见他，
Thalidomide was eventually withdrawn from the worldwide
最后就
market.
下架了。
The fact that this tragedy was allowed to happen and go on for so long emphasizes how little control many governments actually had over medicines just 50 years ago. In Britain, for example, the Arsenic Act and the acts that followed it had put existing drugs and chemicals under some sort of control. But there was still no effective regulation of newly discovered drugs. After the thalidomide scandal, new laws were passed here and in other countries, which meant that in future drugs had to be safe,
后来
they
新
had
法
to
律
be
就诞生了
effective, and doctors also had to tell their patients if they were being given
要
something
测试
experimental.
安全性、
Because
有效
astonishingly
性，
enough, before then, a
医生也要
doctor
主
could
动
give
告
you
知
pretty
病
much
人这
what
是
he or
实
she
验用
wanted,
药。
and they didn't have to tell you.
以前
These
是没有
days,
这些的。
pharmaceutical companies wishing to launch a new drug have to go through multiple clinical trials to demonstrate that their drug is safe and effective.
有效
It
性
can
跟安
take
全性。
years and cost billions of pounds. But it's only by doing this sort of rigorous testing that you discover if a drug has significant toxic side effects.
所以送到每一个人手上的药应该都要是安全的。
It essentially creates eventually a gold standard for how drugs would be evaluated.
Thalidomide led to much tighter regulations, which was a good thing. But the story of thalidomide does not end here. Thalidomide seems to cause birth defects by blocking the creation of new blood vessels. Growing limbs
有
are
抑制
particularly
血管
vulnerable.
新生的作用。
It is clearly a very dangerous drug. Yet this notorious chemical has been found to have beneficial effects. For example, when it was given to people with leprosy, their skin lesions turned from this to this. Literally, overnight. And it's also being successfully used on a particularly hard-to-treat form of cancer, multiple myeloma.
多发性骨
Rise
髓
and
炎
fall and rise again of thalidomide illustrates just how tricky medical research can be. In one context, a drug can be a poison. In another, a lifesaver. Despite the challenges, and with tighter regulations in place, medical research continues apace. While some still focus on mineral and plant poisons or build synthetic ones, others are now driving forward into the dangerous world of the microbe. Although they are only microscopic, microbes can produce toxins which are real heavyweights. And the ultimate microbial poison we have purified and tamed is a toxin produced by the microbe Clostridium botulinum. Botulinum toxin is the most poisonous substance known to man. Now, a couple of teaspoonsful would be enough to wipe out every person in the UK. And a couple of kilos would kill every human on the planet. Fortunately, this is sugar. But I do have some botulinum toxin, better known as Botox, over here. Only a few nanograms, but it is botulinum toxin nonetheless.
就是肉毒杆菌啊。
The toxin is produced by bacteria and was first discovered in poorly prepared sausages during the
一开
18th
始在
century.
这个加工或是保存不良的肉品或香肠里面发现，毒死了很多人。
On the LD50 toxicity scale,
看看它的 LD50，
Botox measures just 0.0000001 milligrams per kilogram. The deadliest of the deadly. A lethal dose for me weighs less than 1 cubic millimeter of air. Botulinum toxin, like curare, commonly kills its victims by causing respiratory failure. But unlike curare, you're not going to be able to keep someone alive with a pair of bellows because botulinum toxin lasts much longer. You have to keep them on a ventilator for weeks, if not months.
它的那个就是作用是比 curare 还要长的。那它的作用是什么呢？
Nerve signals.
阻断神经跟肌肉的连
Botox is
接。
an enzyme which enters the nerve and destroys vital proteins. This stops the communication between nerves and muscles. Only the growth of new nerve endings can restore muscle function.
只有到新的神经重生之后，才会再有作用，所以持续的作用很长。
means it destroys nerves. Now, oddly enough, that makes it useful for a number of medical conditions, ranging from eye squints to migraines, from excess sweating to leaky bladders. But its main use, of course, is ironing out wrinkles in aging faces. It does this by destroying the nerves that cause frowning.
因为可以减少神经对肌肉的控制。
tiny, a few billionths of a gram dissolved in saline.
剂量很小很小
In the
很
name
小
of
很小。
science, I tried Botox a few years ago.
Wasn't painful, was it?
No.
It certainly smoothed away the wrinkles, but it also gave me a weird expression until the new nerve endings grew back.
但会失效啊，新的神经长
It
出
may
来
not
之
be
后
to
就会
everyone's
失效
taste,。but Botox is certainly big business. Costing around 100
极大的
trillion
商机啊
pounds per kilo,
各
Botox
位
is
加
the
油啊
most expensive product on earth.
但是也很贵，所以一针很贵，是因为它原料也很贵。
Huge amounts of money can clearly be made from new medicines, so it's no wonder that the search for them continues. Having
新药的
started
商
out
机
by
很大，
collecting exotic poisons extracted from
然后
plants,
从毒物
such
这
as
边来
curare,
获
we've
取
come
新
full
药，也是一
circle.
种方法。
As well as microscopic life, researchers are intensely interested in studying some of the other ingenious killers of the natural world. Killers that scuttle, slide, and slither. In this room there are over 250 snakes, spiders, scorpions and other venomous creatures. Their venoms have evolved over millions of years and they're all different. The hope is that amongst this lot there are some which could lead to a significant medical breakthrough. One of the greatest medical challenges is still cancer, particularly cancers of the brain. Brain tumors like this one here
Cancer 还是里面最难治疗的。
If you use radiotherapy, chemotherapy, you risk damaging healthy tissue. If you can get at it and cut it out, then that's good, but also it's quite difficult sometimes to tell the difference between tumor and healthy tissue.
使用 CT 的话，其实对于 cancer 部位的判读，尤其是手术的时候，还是有它的难度的。你不知道切多少。
Even though on a scan you may see a tumor that looks, let's say, 2 centimeters in size, we know that there are tumor cells several centimeters away from that ball of tumor. So to entirely remove everything, you would really need to be able to remove all that surrounding tissue, most of which is normal brain.
不伤到正
Removing
常
healthy
细
brain
胞，
tissue
尤
could
其
mean
是
the
脑袋，
difference between walking and not walking, seeing and not
要
seeing,
不然很容易造成一些
talking or being
就
mute.
是后
And
续
so
的一
being
些
able
后
to
遗症。
pinpoint unhealthy tissue is critical, which is where venomous animals may be able to help. This is Lirius quinquestriatus, also known as the death stalker. As her name implies, she is a particularly venomous scorpion. A single sting from that tail could probably kill a child or an elderly person. Although probably not kill me, it would certainly be excruciatingly painful. The venom of this scorpion contains a powerful cocktail of neurotoxins, chemicals that poison
有很
brain
多
cells
神
and
经
nerve
毒素
cells.
对于神经很多的脑袋有什么作用
One
呢？
is
可以
called
看看
chlorotoxin.
chlorotoxin。
Chlorotoxin affects the nervous system of insects, utterly paralyzing them. But when trialed in human tissue, it did something completely different. It seemed to have a special affinity for cancer cells.
The compound
它对于
bound to
cancer
the
cell
tumor
的亲和力
and
不同。
avidly bound. In other words, once it's stuck, it stayed stuck.
Chlorotoxins from the scorpion venom bind tightly to receptor sites on the surface of the cancer cells. These are called
所以这个
annexing
毒素对于
A2.
cancer cell 的
Unfortunately, the
表面细
chlorotoxin
胞
is not strong
嫁
enough
接
to
力很
actually
强，
kill the cancer cell.
但是又
However,
不
when it's
足以
mixed
来
with
杀
the
掉这个
fluorescent
cancer 细胞
dye,。it highlights
那可以
cancer
怎么用
cells,
呢？
allowing
他们
surgeons
用
to
了一
avoid
个
cutting
荧
out
光定位
healthy brain tissue.
实验法。
It can be visually extremely difficult to differentiate tumor from normal brain. They look alike, they can
肉
feel
眼不好
alike.
判断的
So
话，
the ability to fluorescently identify
加上
areas
荧
that
光
are
就很好判断
abnormal
了。
based on the fact that they bind chlorotoxin and then remove that tissue is extremely appealing. So in the operating room, we would simply switch our imaging system to a system that shines infrared light and just look at the picture
荧
that
光
we
显
see.
上，
The areas that light up blue should be just tumor. So you can detect microscopic amounts of tumor.
有反光那边就
It's
是
promising
癌
research
细胞组
in
织。
just one area where this venom could offer medical benefit.
Been a long process in development, lots of twists and turns, but I'm looking forward to where the future goes with this. It certainly has the potential to be very, very promising.
所以毒物的发展
Produce a
潜力
huge
还是很
range
高
of
的。
different venoms, and many have been shown to have remarkable properties. Venom from snakes has led to the production of a new type of antihypertensive drug for treating high blood pressure, while the lethal cone snail has produced one of the world's most powerful painkillers. So who knows
其
what
他
other
的可以
medicines
用来
might be
做
lurking
血压
in the
药、
fangs of the
止
creatures
痛药
behind me.
等等的。
Venoms are particularly appealing to modern researchers because they tend to be very specific. They seek out precise targets, which ties in well with another medical revolution that's going on. It too builds on the idea of targeting, but this time it's targeting at a genetic level. Medicine is getting truly personal. The trouble with dishing out the same drugs to everyone is that we are all different. A drug that lowers my blood pressure might have absolutely no effect on yours. So how close are we to creating truly personalised medicines?
What we've found as we've sequenced the genes of a number of people is that everybody has slight variations and subtle changes in their genes, and these
讲到精准医疗
ever so
从
slightly
基因
subtle
层面开始
differences in the ways that cells respond to drugs. The concept is that we use that information to really tailor a specific therapy for that one person. We're doing it to some extent already. Right now, what we can do is sequence the relevant bits of the person's cancer genome for about the same cost as many of the scans that we do for patients with cancer, the similar sort of cost as the pathologist looking down the microscope at the slides from that person's cancer. So I think it's very likely that over the next 5 to 10 years or so, these kinds of genetic approaches
所以现在已
will
经
make
做
their
到
way into
个人化医疗，针对你个人的 cancer 去进行序列分析。
Personalised medicine is set to be the next big
然后
step
再个
in
别
a
给药。
process that started in the early 19th century. Since that time, our medical world has been utterly transformed. We no longer expect to die young. Instead, the threat comes from diseases of old age, like cancer. Here, poisons have proved to be particularly useful. Even arsenic, the murderer's friend, has now found a medical use as an anti-cancer agent. Thanks to medical pioneers, we now know how to control pain. Infections are not the death sentence they once were. And doctors use many poisons on a daily basis. Years ago, there were very few effective treatments. Now doctors are talking about targeted, specific, personalised medicines. We have come a long way, but we still have a long way to go.
好，那我们先下课休息10分钟，等一下来就是重点整理，然后整理完就可以下课。好，10分钟。好，那我们先来复习一下这次影片学到了什么重点。那第一个部分，它是讲到 curare 亚马逊河流域，然后发现的箭毒素。那一开始呢，我们看到他拿了驴子做一个实验，发现它有一个就是自由基的一个麻痹作用。其实并不是在呼吸机的部分，因为如果大家想，如果只有呼吸机的部分，那驴子是不是可以乱跑？对啊，所以它不是只有，它这是有个顺序的。像肌肉麻痹啊，一般如果大家在看麻醉啊，或是在看一些相关的 muscle relaxant 的话，呼吸机基本都是最后才抑制的，因为人体的功能嘛，你手啊、脚啊这些骨骼肌类可能会先麻痹，然后再来就是往比较内脏。那呼吸是就是生存最必要的根本，那它的抑制的话，通常都在最后面的。那现在的话呢，它作为手术上的一个肌肉的放松，可能也有一些插管辅助，像 tubal curare 这一些的。然后呢，这样我们我临床的一个医师，一个大学长，他跟我讲说，tubal curare 呢，他每次都跟他学生讲一个故事，他说哪一个敢在 PGI 或是敢在样的时候 tubal curare 敢开 IV 的，当掉重修。你就知道这个药其实有多么他是说，反正任何的就是他说讲一些 local 的东西啊，对，如果你敢打 IV 的，他说这个直接让他 完全记住这件事情，重修当掉。然后所以为什么大家可以看到 curare 它的那个 LD50 很低嘛，所以如果你用到那个全身的话，其实是很危急的情况。所以其实 tubal curare 现在用在插管辅助的话，大概只有麻醉科医师跟急诊比较资深的医师敢用而已。其他的话，如果说一般像插管的话，除非真的很难放的，要不然他们不太会用到这个，只是用来辅助而已。麻醉科啊，如果我看到比较多麻醉科学生会用。好，那第二个，接下来我们看到就是一个有保险引发的谋杀案 ，Mary Ann 嘛。那砷中毒的话，它就是用来就是做检验的方法，这其实比较像法医学的部分哈。它是在肠胃的器官进行取样，然后用铜，就是加上铜跟酸的方法去检测。后来它的有效成分3氧化2砷呢，也被用来当做老鼠药，所以现在目前好像没有人用的药品啦，就我所知好像没有。中药的话我不敢确定，西药部分。然后一开始的时候被管制购买、限制购买，然后要登记啊等等。那现在的话比较明显，大家现在看到老鼠药一定是有颜色的。红色啊，这一些就是比较明显的颜色区分，让小朋友啊或是一些比较就是不会误食。那他当然也讲到说，比较不会有就是之前就是老鼠药啊跟什么茶、咖啡啊都放一起的这种误买的一个情况。然后第3个部分讲到的是那个 atropine， 那他用了一个实验去证明说那个瞳孔，那瞳孔放大这个东西呢，大家听听就好。瞳孔放大的一个副作用就是你会视觉模糊，所以比较经典的一个例子，如果有点近视眼的小朋友，那他都会交代说睡前再点，或者有青光眼老人家睡前再点，点完之后休息，不要到处走。为什么？因为你到处走，你就会跌倒，因为你那时候瞳孔是放大的，然后视力是模糊的，所以如果这是你会不能维持在正常的那个睫状肌收缩的一个状态，所以那个时候去看东西是不清楚的，然后是模糊的。那个为什么点近视眼呢？因为那个近视眼的话，它大概前期有个假性近视的部分，然后用那个 atropine 去散瞳，然后另外一个就是散瞳剂也被用来，如果做眼科手术的话，你要去就是有一些眼科内的手术，那瞳孔一般的时候，尤其紧张的时候，它缩得更小，交感嘛。那学到这边的话，一定要用交感、副交感的那种，就是这种逻辑去看。交感、副交感的时候，就是如果你刚刚讲说交感应该是散瞳的，那个如果你用副交感来看的话，就是它是放松的情况。所以放松的情况包含什么？心跳就会变慢啦，然后呢，就是你肠胃会分泌啊、蠕动啊，因为放松的状态嘛。然后呢，就是那个你可能会那个缩瞳啊，所以缩瞳。然后在交感的话，交感它就是 fight or flight， 就是打或跑，所以交感一定哈瑞要快，然后你全身的 epinephrine 要上来，然后呢一定要散瞳，看得够多，免得哪里有野兽之类的。然后呢，你全身上下都是在一个备战状态，所以交感的话，肠胃不会蠕动很快，因为肠胃蠕动这时候没有意义，你要跑或是要打。OK， 那atropine它是什么呢？它是副交感的拮抗剂，节字写错。好，副交感拮抗剂，副交感是放松的，所以它的拮抗放松，所以副交感就是类似那个atropine就是类似有点交感的作用，所以它不只可以用来散瞳，它还可以用来增加哈瑞。所以在 ICU 的时候，如果病人哈瑞超慢，然后再打一支什么？打一支有些人会用 epinephrine 会有，但是如果他血压如果这时候也比较高一点，然后这时候有一些人像他们有时候会选择就是直接给他一下 atropine， 给他下去，那哈瑞就上来了。为什么？因为副交感是让控制心脏的主要是副交感，那副交感会让心跳变慢，所以你拮抗了副交感，你用了 atropine。它就会拮抗副交感的作用，所以副交感抑制消失了，心跳就会变快。OK， 这就是一个学历的部分。神经毒气解毒这个，如果大家后续在爱国教育啊，或是一些医务所啊，主要是医务所啊，如果有机会去到医务所的话，长官很喜欢问的一个问题就是， 如果今天战场发生了神经战，这个就是神经毒气，或者说就是那种毒气战，怎么办？大家如果还有一些就可能在一些医疗史上会看到说什么东京沙林毒气啊，或是一些地铁毒气事件，他用的这些都是就是强力的一个副交感的一个毒气，还会让你就是什么就是会倒地啊，肌肉不受控制啊，然后甚至口水啊、眼泪大量分泌啊，然后甚至严重就是小便失禁。为什么？因为这都是副交感的作用，大量分泌唾液啊这些的都是就是大概有的都是副交感作用，然后瞳孔缩到跟那个针一样啊，类似这种感觉就是。然后呢，这时候呢，atropine 它就是一个神经毒气解毒剂，所以以前在部队的话都有备 atropine， 那不是拿来用的，因为部队不会用到 heart 的部分，那个一定是转诊，它就是备来用为神经解毒用，但是最好不要用。好，那以下是它 atropine 的中毒的话，就是用那个 physostigmine， 这是以前的做法。那个解毒剂的话，就是用一个副交感致效跟副交感拮抗这样两边的一个就是作用，让它去就是解 atropine 的毒。不过现在比较常看到是 atropine 去解副交感的一个毒性这样子。好，那接下来一个部分，他们讲到一战那个化学毒气。那后来发现在那一些有吸入到这个介子弹的一些军人，他们体内的白血球观察到有非常非常低的情况，所以他们就在就是他们就在想说，如果这样子的话 ，Goodman Gilman 两个嘛，大家嘛，他们就在想说，如果这样子的话，那是不是在对于就是恶性白血球增生的病患是不是有好处的？所以果然就是大师是大师，看的点果然不会就是只看到那个一般人看到，所以后来他们就用了就是病患嘛，刚刚看到那个一个波兰裔的一个男子，那就把它用来治疗白血病，然后发现他的肿瘤有缩小，但很可惜的是他6个月后还是过世了。不过呢，就此还是开启了化疗药物的一个开发。那通常化疗药物的话，对细胞都是有伤害的。什么掉发啊，然后一些什么肠胃副作用啊、恶心呕吐啊，这些都很正常。掉发原因就是因为它对活的细胞是有害的嘛，所以头发是生长很快、代谢很快的一个细胞，所以它就会被影响到这样子。好，毒。那刚刚我们讲到就是 LD50， 那到底什么是 LD 呢？是 lethal dose。通常 LD50 呢是指说给予这个定量的剂量之后，会造成这个测试族群，比如说老鼠，比如说人 50% 的死亡几率。那这边如果以人来讲的话，水的 LD50 的话，大概在9万 mg per kilogram。那 curare 的话是在 0.5 mg per kilogram。那大家后来有没有看到那个就是肉毒杆菌 Botox 那个是 0.00006 个0，然后那个6个0，然后1 mg per kilogram， 所以肉毒杆菌是目前世上已知最毒，我们知道的最毒的物质啊。那化疗药物呢，它通常是在1到4，然后它刚刚影片是说低于100的话就会被定义为毒物，所以毒的部分是这样来的，所以不是只有毒物才会造成中毒，咖啡喝多也会中毒，水喝多够多来说也会中毒，渗透压嘛。好，那后来讲到撒利斗买，然后早期的时候被治疗孕吐，然后但是后来发现那个出现了很多海豹之宝宝。那因为美国的就是 FDA 官员对于新药审查坚持，所以后来这个案件也促进了新药上市前的审查机制。它的影片中，如果大家可能提到，它是要花了数十亿美金，然后这个药物才能上市，所以药卖贵一点点就贵一点点啦。这个就是他们前期是很辛苦的，药厂也是能撑下来的不多啊。好，那后来撒利斗买被用来治疗多发性骨髓瘤，因为他影片中有提到，他们在怀疑可能是因为撒利斗买它有抑制了血管新生。那为什么是四肢呢？大家知道新生儿在成长的时候不是一下就长好，它是从有顺序的嘛，就是什么先长什么后长，然后四肢什么时候长，类似它那时候抑制了血管新生的作用，所以它的四肢发展就会不是很健全。 这是它的。那现在被用来治疗多发性骨髓瘤，刚讲的介子弹跟撒利多玛现在都还在用，临床上的化疗病人都还在用。那禁忌就很明显啦，不可以用在孕妇身上。好，最后是讲到肉毒杆菌，那它是之前被发现在有那个加工品，如肉类或香肠保存不良的食物中毒。那它有基本上目前已知最低的 LD50，它的一个作用是神经阻断，然后现在被用来就是作为医美领域，然后这一支很贵。然后因为刚讲到为什么打一针不能够持续永久，是因为它神经肌肉阻断之后，等到新的神经长出来之后，它的效果又没了，所以打了一针就下一针，还有下一针，还有下一针，就是这个意思。所以大家有兴趣往这方面的同学可以积极努力啊。好，那最后讲到评量部分，那之前的主代老师有跟我讲过，因为上次讲的可能不是很清楚，所以后来主代老师跟我还有这一堂课另外一个老师，我们有讨论了一下。那因为大家对于评量方式跟那个缴交期限都有一些就是提出一些讲法，所以我们后来讨论一下，然后在这一次的话，我们就整合完了。那因为另外一位老师他是出1000字的心得，所以我这边的话也是出1000字。那1000字的方式就是这边有没有写？我这边的话是用6选2，因为之前我说一个题目500字嘛，那后续的话，那个我这边的话就是把它改成大家自由选择2个题目，那各500字，所以也是1000字。那所以如果已经写了第一个题目了，不要担心，就是你写那个再加上一个500字，一样就等于这一次，就是选了上一个题目的同学啦。然后如果你已经写了500字，然后你现在发现怎么会这样？其实没有，就是因为是你选了一个写了500字，其实我们现在把它改成选2个各500，所以其实一样，你写了一个，那个不会白写，那个一样是写完。然后现在我们的做法就是我这2堂课的都一样，就是选2个，我这边出的主题选2个各500字，加起来1000。另外一位老师也是1000，然后我们把评量方式跟我们的打分基准都商量好了，所以大家照这个去写，内容跟评量方式我们是基本上都是一致的，所以大家不要太担心这部分。那这一次的题目有什么呢？包含像箭毒类药品的药理机转及应用，比如说 tuberculin， 那胆碱类致效剂，比如说 physostigmine 或是 atropine 等等的，然后药理机转及应用。那 mustard gas 的一个机转及化疗应用 ，thalidomide， 然后肉毒杆菌，或是其他影片中提及与药理相关的题目。那一样，我们的概念就是选其中一个药品，然后去做一个就是查询药品它的一个应用及药理作用的一个查询。好，那题目的话就在这边。那相关的话就是包含像我们讲到的化疗药物，或是你看到其他的胆碱类，或是拮抗剂或致效剂等等的一个应用，不在这次提及范围内也可以，就是相关的药理、相关的药物都可以。好，那这个都一样，就是比较主要就是一个题目500，所以2个题目1000，6选2，6选2，6选2。OK， 那所以上次写了上个主题的500字，那个不会白写，你只要再挑一个500，加起来就是1000。所以这一次一样，1加1 1000。上次你说一个题目已经写1000，是不是？哇，这真的是，你等一下来找我一下，我来讨论一下。你说上一个题目已经写1000了。那我就只好酌情给高分，要不然那个，因为那个这就很麻烦，因为我们就是前面我以为是我打我自己的部分，然后其他老师打其他老师的部分，所以我还是维持这个因为后来我们共议，就是因为我只出一个题目500，然后另外一个老师出他的题目好像比较他的那个好像比较多一点，然后他说是1000，所以我还是把它出成2个题目1000。那如果你字数变多的，我当然就是看你写内容，如果好的就高分啦。因为他也是写至少1000，他也不是说最多你只能写1000，所以你大于500当然是可以接受的啦。就是一个题目还是2个主题，对，还是2个主题，对，我就是这边是6选2，然后一个500，你写一个 part 就500。 一个 part 500加起来，这样就可以了。OK， 那缴交时间，因为这一次就是我们公示完之后，我请另外老师把作业缴交时间全部都改到5月5号是 deadline。那我这边写5月4号，只是先大家提醒一下，我们5月5号截止，所以5月4号的晚上之前啦，最好不要拖到5月5号。那5月5号是他开的那个缴交期限的最后 ，OK。那这边跟上次一样就不赘述了。好，那这次的部分就到这里。那希望这1、2、3节课的内容，虽然都是影片，但是我觉得它里面带到的部分有蛮多是或许在某一个点对各位可能大家不同领域后续钻研上可能有一些启发。所以希望这几堂课内容可以为大家带来一点不同的想法思考，那也可以让大家更确定以后有些什么样的方向可以去追寻一些，甚至一些你想要研究的领域。那这就是我们上这堂课的一个比较主要的用意。那目前我们就到这里。好，如果没有问题的话，我们这堂课就到这边。